Yeah! We are going to talk now about the physical pendulum. Everybody loves a good physical pendulum. Let's have one. So, it's the same argument as before. We're going to have, except that now we're going to have an object that's not so simple. It could just be a bar. It could be a bar with a mass on the end. It doesn't matter. The difference is now that instead of looking at the forces, we're going to look at the torques, or the torque on the system. So, let's say the center of mass is here. Then, instead of mass, we're going to deal with moment of inertia. And the torque, which again is going to act like this, we're going to have the same angle theta, and we'll call this distance d. D is the distance from the center of mass to the pivot point. Okay, in this case at the top. So if we want to find the torque, it's going to be the restoring force, or D, times the restoring force. And we make the same argument we made in the other video, that if the force of gravity is acting down on it, then this is the angle theta, and this force over here on this side is going to be mg sine of theta. And that means that the torque is going to be d times mg sine of theta, which again we use the small angle approximation to call this torque equal, I'm sorry, I'm going to call that minus because it's restoring. Okay. It is going to be minus d mg theta. Well, we know torque is related to the acceleration of the system. Torque equals I fish. And remember that the angular acceleration is just d squared theta, d squared theta over dt squared equals the torque. Well, that turns out beautifully. I mean, you couldn't do better, because we have now minus d mg theta equals I d squared theta over dt squared. And I'm going to rearrange this to take the form d squared x over dt squared equals negative omega squared x. But again, it's going to be in terms of theta. So it's going to be d squared theta dt squared equals mg d over I. Let's make sure we like the units. mgd is going to be basically, remember, it's going to be the same as joules, which is kilogram meter squared over second squared, all divided by kilogram meter squared, because that's the moment of inertia one. So those go away. We have 1 over second squared, which is radians per second squared. Oh, I'm in love. That's exactly what it should be like. And this also works out nicely because now we know that, sorry about that, now we know that omega squared equals mgd over I. So we can make all the same pronouncements that we made before. Omega is going to be the square root of mgd over I. Okay. And that means that the frequency is going to be 2 pi omega, which is 2 pi square root of mgd over I. Is that right? No, it'd be 1 over 2 pi. This would be omega over 2 pi, my fault. So this would be 1 over 2 pi. And that means that the period is going to be the inverse of that, which is going to be 2 pi times the square root of I over mgd. And let's see if we like this. If we have more mass, or more moment of inertia, it's going to be more difficult for it to swing. That's going to make our period less. That's good. Okay. Or sorry, no, it's going to make our period more. It's going to make it move slower. That makes sense. If I have the same mass, but it's way more difficult to move. So if I have a really big mass, so then I have a really big force, but I don't have much of a moment of inertia, I'm going to end up with a small period, which is good also. Let's try this for, say, a bar. A bar swung at the end. Okay. So that's going to be our example. Bar, a uniform of mass m and length L. Okay, what's the period? Well, the period's going to be 2 pi I over mgd. Well, let's go through and look at these. I is going to be, because it's swung at the end, it's going to be 1/3 ml squared. D, because it's the distance from the center of mass, not the distance from the other, or distance from to the end, is going to be L over 2. So let's reason that out. Okay. 2 pi, going to be big. Okay, 1/3 ml squared over mg L over 2. The masses divide out. We get 2 pi. We end up with a 3 on the bottom and a G on the bottom. One of these L's divides out also. We end up with a 2 on the top and an L on the top. And that's our period. 2L over 3G. 2/3 L over G. And it turns out pretty nicely.
Dad, how much money are we supposed to...
Sorry, guys. We had a burning question about the amount of money we're allowed to spend on Christmas gifts for our cousins this year. But the point is that this works out exactly the way you would expect it to. You know, that you still have L over G. In fact, just for our own amusement, we can check a simple pendulum. So with a simple pendulum, we have a length L and a mass m. And in this case, I, because it's a point mass, we'll call the string very light, is going to be ml squared. And d, since it's the whole length here, is going to be L. So if we put that in, T equals 2 pi I over mgd we get 2 pi ml squared over mgl. Those go away. And look at that, 2 pi square root of L over G. Love it when a plan comes together. So, that is the physical pendulum. And we'll do a lab and stuff on it too. I want to make sure it's on there. I got burned about 2 years ago. I spent like one day going over this, and it was an entire problem on the test. And then they did put it on a problem again, so I don't want to get burned. That's why I want this to be a video too, so that you have that to review over and over if you need it. All right, and thanks for your attention, guys. I'll see you on Monday.